All right, we're going to talk about atomic structure right now. We're going to talk the atoms. Atoms make up all things. Atoms are the smallest part of any object. Um, each of the elements are made up of an atom, individual. 90% of all the mass of the whole universe is made up of the first atom of the periodic table, hydrogen. 90% of the mass of the whole universe is hydrogen. That's huge because it's the smallest and therefore the lightest atom we have. But still 90% of all the mass. It's crazy, man. Cray cray. All living things, animals, plants, and bacteria, are composed primarily of atoms of oxygen, carbon, hydrogen, and nitrogen. The big four. Yeah, I'll make it. Made up of carbon, oxygen, hydrogen, and nitrogen. Okay? So primarily, your body is made up of a combination of these four. If you look on page 10, there's a pie chart there. And pretty much 61, that's 84, 94, yeah, about 100, almost 100% is five, are these four right here, these four elements. Put that over there, atoms. Center that. All right, that looks pretty, doesn't it? Okay, now we're going to talk about the structure of an atom. All right, let's talk, all right, structure. Structure of an atom. Excuse me. All right, let's say the circular object. I didn't put that where I wanted to. This object is a um, is a atom, a single atom. This right here is the atom. On the inside of atom is what's called a nucleus. Let's just make this the nucleus right here. I don't know. Can I change that color? Let's see. Wow. Am I talented or what? Yep. This is the nucleus. Vivian, say I'm talented. Thank you, Vivian. You get an A for the day, atta girl. All right. In the center of the nucleus are two things, protons and neutrons. Protons are positively charged particles. Neutrons are neutral. Neutrons, neutral. Makes sense, right? So you have positively charged particles, protons. Let's try to figure this out. Let's see if I can do this. Can he? Yes, he can. Look at that. That's amazing. I am the bomb.com on this. Okay, so protons are positive, neutrons are negative. I'm sorry, protons are positive, neutrons are neutral. They have no charge at all. However, these two parts of the atom make up pretty much the whole atomic mass of the atom. The mass of this plus the mass of that is pretty much the entire amount of the atomic mass of the entire atom. Now, so basically, anything inside the nucleus, that's where your atomic mass comes from. Everything else is too light. We really don't measure it. All right. So if the protons and the neutrons, the positive charge and the negative charge, are inside the nucleus, well, guess what charge does that make the nucleus? The whole nucleus is charged. What charge is it? Well, it's a positive and a neutral. It's going to be positive, correct? Makes sense? Now, circling let's do this. Circling, I like this even better. Circling this positively charged nucleus are something called electrons. Electrons are negatively charged. So that's, if you have a positive and a negative, what does that do? They're attracted to each other or do they repel each other? These are negative signs. Get it? Pretty good, huh? So we have positives and negatives. Positives are in the center, negatives are on the outside. What is the what are the negative charged atoms or negatively charged particles going to do? These electrons. They're going to circle around this because it's the negatives are attracted to the positive. And they keep spinning around and around and around. They don't go inside the nucleus. They are just moving around the outside of the nucleus. Now, we really don't know where an electron will be at any one time. They're very, very small. They have almost no mass because they're so small. And they're move very fast. So what we say that they're in an electron cloud. So we'll say we know how many electrons there are going to be in this general area. We don't know exactly where, but we know that they're going to be in this general area and how many of them are. Like there's 6 here. We know there's going to be 6 electrons out in this electron cloud right here. All right, so we're talking about atomic structure. Atomic structure is in the center, what's the nucleus of an atom, is protons and neutrons. They're in the center of sorry. They're in the center of an atom. It's what's called the nucleus. Protons are positively charged. Neutrons are neutral. They don't have a charge. Circling this nucleus, this nucleus is positively charged because there's positive protons, but there's no charge on neutrons. So positive and nothing is positive. Circling this nucleus will be negatively charged ions called electrons. So these are electrons. I don't know why that showed up there, but we're going to get rid of it. How's that? Um, Negatively charged electrons. So positive in the middle, surrounded by electrons that are negatively, that we don't know exactly where they are because they're so small that and move so fast that we can't pinpoint exactly where they're at. So we call it an electron cloud. Now in the center, we have protons, and the protons are what makes the atomic number. When we look at the periodic table, so when we look at the periodic table, let's go over here. There it is. All right, this is the periodic table. When we look at the periodic table, this very top number, let me see, what can I color it black? This number right here is called the atomic number. All right. The atomic number there is 1, over here is 2, 3, 4, 5, 6, 7, 8, all the way. It's numerical, right? But what this atomic number also tells us, it tells us how many protons are in the nucleus. So if we say that there's 6 protons in here, or let's just say 8 because we have 8 electrons. So we say we have 8 protons in here. We go to the periodic table and we can see, hey, element number 8 right here, this element right here is oxygen. It has 8 protons. We know it has 8 protons because the number of protons is the number of its number on the periodic table. So if I give you how many positives are on the inside of an atom, you could tell me what atom it is. All right. Let's say I look at this element and I see 12 protons. And Gage could go over, or Nisa could go over here and look at this and say, that's magnesium. Mg is magnesium. because they can look at the periodic table, and those two both know that the number of protons equals the number on the periodic table. Okay, so the top number on a periodic table above each element is the atomic number, and the atomic number is equal to the number of protons in that element. Okay, so let's go ahead and make our own periodic table here. And yeah, let's try this. So I'm not sure that's what I wanted. I wanted a rectangle. They don't have rectangles. I guess I have to use it. All right, so we know that right here is periodic number. So in the top center of a periodic table square will be the atomic number of any element that we're talking about. And what does that atomic number do? What does that tell us? Right, it's positive. Okay, so this tells us that there's 12 protons, correct? This number right here tells us, hey, we're talking about 12 protons, and since we know there's 12 protons, we can go to our periodic table and know that element number 12 is magnesium, Mg. So, oops, wrong way. So the other thing that we could do is we could also put in here, first letter is capitalized, the second letter is not. Let's see, can I make that bigger? Yeah. So then we know it's 12 protons. We go to the periodic table, know the element 12 is magnesium, Mg. We put the symbols there. All right, so we have our magnesium here. Let's go back to this. Now, we get our atomic number from this. We get our atomic mass. Remember, only protons and neutrons really have any weight. So protons plus neutrons, the nucleus, is what gives us our atomic mass units, our atomic mass number. If you look at right here, black pen, there we go. Right here, the bottom center is where the atomic mass is. The atomic mass number. So for our element number 12, magnesium, 24.3 would be the atomic mass number. So 24.3. That's not going to work. So the bottom center is the atomic mass number. Those are measured in AMUs, atomic mass units. So the atomic mass number is the center bottom. The atomic number is center top. And in the middle here is our symbol for whatever element we're talking about. Now we have 114. We actually have 118 that we know are out there, but we only know for sure about 114. Okay, so we know how to get our numbers out the periodic table. We get the atomic number from the number of protons. Number of protons in the nucleus, just the P's. We get the atomic mass. That's an average of all the magnesiums are out there. This is the average atomic mass. That is protons plus neutrons. Now, how do you get that 0.3? This 24.3. All right, so the average number of protons and neutrons is the atomic number, or atomic mass, I'm sorry. How do you get the 0.3? Well, there's something that's called an isotope. Let's put that in. Oops. What's the isotopes? An isotope, according to the book, is the atom of the same element that have different number of neutrons. Okay. Now protons are set, right? if you're going to have a lithium element, it's got to have 3 protons. There's no way it could have anything else because if you have more than 3 protons, say you have 4 protons, that's beryllium. So it wouldn't be lithium anymore. So if you're going to have lithium, you have to have 3 protons. Now, we know that atomic mass right here is protons, which we know there's 3, plus neutrons. Well, the neutrons are the unknown. Now, sometimes, look, it's almost 7 is the atomic mass. Sometimes it'll be 4. Most of the time it'll be 4. That's the average. Sometimes there's only 3 neutrons. Sometimes there's 5 neutrons. Actually, there's one isotope that has 8 neutrons. There's also one that has 3. There's a lot of times they have 3. So the average of all the isotopes out there is 6.9. So an isotope of an element, whether it's hydrogen, helium, sodium, potassium, whatever it is, it's going to be the protons, which is the atomic number, so 1, 3, 11, 19, 37, and its neutron. Neutrons vary. The protons do not vary. They're set. If you don't have 3 protons, that's not going to be lithium. It could be, if you have 2, it's going to be helium, right? If it's 4, it's going to be beryllium. I'm going to erase that, all this stuff. I've got too much on here. I can't even follow it anymore. All right, so protons are what? The atomic number. The atomic mass is the protons plus the neutrons, and it's the average of all of them. Okay, look at hydrogen. You have 1 as the atomic number. So what's that tell you? That you have 1 proton. But the atomic mass is 1 too. So what does that tell you? In hydrogen, normally there are no neutrons. It's just 1 proton. That's all that's in the nucleus. All right. Questions? Okay. All right. So these different isotopes with different protons and different neutrons, or same protons, different neutrons, we name those by saying the particular isotope and then how many protons and neutrons it has. So if we're talking about oxygen, most of the time we'll be talking about oxygen 16. Sometimes there's oxygen 14, or carbon, this is a good one, carbon 12. We could be talking about carbon 12, and we'll say C12. Or if we say carbon 14, that's talked about a lot too. That's a radioactive element. It's one of the isotopes that is radioactive. So carbon 14 is talked about a lot. That's the carbon that's actually found in all living things. You've heard of carbon dating. Nice hands, Nisa. You've heard of carbon 14. And we can measure that and come up with an approximate age that something was alive 5,000 years ago. All right. So one other thing we're going to talk about, ions. What is an ion? An ion is the same element, but it's either gained or lost an electron. Now, electrons don't have a lot of weight, don't have much weight at all, so we don't even add those into the AMU, or atomic mass units. But an ion is of the same element where it's either gained an electron or more than one electron, or lost an electron, or lost more than one electron. So if we just say carbon, we're taking it for granted that carbon has, okay, look right here, carbon. Carbon is the 6th element in the periodic table, right? So how many protons does it have? Emma? Yes. Of course you know, it's 6, Emma. So we know that there's 6 protons in carbon. Now, everything in nature likes balance. So if there's 6 positives, how many negatives will there be? Right, 6. The negatives are the electrons. So if we have 6 protons, we have 6 electrons, we have 6 positives, we have 6 negatives. We try nature tries to keep that balance. Now, if we don't have the same amount of negatives as positive, that's called an ion. An ion is found fairly regularly. A lot of bonds are formed by gaining or losing electrons. But an ion is an element that does not have the same number of electrons as it does protons. So I just told you basically how we could, from just seeing this, we could tell exactly how many protons, neutrons, and electrons we have. How is that, Mr. Mansell? Well, let me tell you, kids. Yes, Austin, behave. All right, so let's look at argon. Argon, how many, let me get my magic pen out. How many protons does argon have? Yes, Howard, correct, 18. So we know if there's 18 positives, how many negatives are we going to have? Damien. Damien, wake up. That's right, 18 negatives. So we know protons are positive, electrons are negative. So we know there's 18 protons, there's 18 electrons. Now our atomic mass is, we'll basically round this to 40. So we know we have 18 positives. What plus 18 equals 40? 22. So 22 would be the number of neutrons because protons plus neutrons equals atomic mass. We'll go over that again a little later, just to make sure you got it. So let's pick another one. Sodium. Our friend, the sodium. 11 protons. How many neutrons? Well, in the nucleus, we have 11 protons. The atomic mass is 23. So protons plus neutrons equals atomic mass. So 11 plus what equals 23? 12. So we have 11 protons, 12 neutrons, and if we have, this is not an ion, it's got 11 protons, how many electrons is it going to have? Right, 11. 11 protons, 11 electrons, and 12 neutrons. Okay. That's basically section 1, 1.1. Let's do section 1.2 next.